All right, so let's talk about vectors in the coordinate plane. Okay, so remember what we said about vectors is they have a starting point and an ending point, right? So we can put the starting point and the ending point on a coordinate plane, and then we can really like talk about, you know, how to find the magnitude and the direction and all that stuff. So yesterday we started talking about vector components, okay? So take a look here. If I have a vector A, B, right? And A is the initial point, B is the terminal point. Suppose I were to put them on, you know, like a coordinate plane. So suppose A was at, I don't know, 2, 7. And B was at 5, 11. Okay? Okay, I'll try to zoom in a little bit. Maybe we need to move you closer. Yeah. Okay. So talking about this x component here, right? The red is the x component here. How big is that x component? If I'm going in the x's from 2 to 5, then the x component is how much? 3. And then the y component is how much?
4.
From a y of 7 to a y of 11, that's 4, okay? So let's think about how we got them. We got this value by just subtracting the two x coordinates, right? x2 minus x1, right? I did 5 minus 2, and I got 3. Then when I subtracted the y coordinates, 11 minus 7, I got 4. So those are the components of that vector. So one way to describe vector AB is, okay, if you start at A, you go positive 3 in the horizontal direction, and then you go positive 4 in the vertical direction, and you get to the end point, right? So all I need to do is say the size of the components, and that pretty much is a good description of the vector, right? We say in that case that we have written the vector in component form. So AB in component form will be, you go positive 3 in the x, positive 4 in the y. But how do we, you know, say this is any different from a coordinate point? Well, we use special brackets for it. So that is now the component form of vector AB, okay? So the way in which we write component form is this. Oh, sorry. The component form of a vector is x2 minus x1, y2 minus y1, okay? And so if this is, you know, vector AB, then I say the components, they're usually like little a, little b. So this is little a, little b. But okay, but these are not vectors. These are just like numbers, okay? So the first component is always A. The second component is always B. Okay, so now find the component form of vector AB with initial point this and terminal point that. Okay, so AB is going to be, okay, you cannot mess up the order here, right? It has to be terminal minus initial. So it's going to be 1 minus 1, 3 plus 3. So AB is 0, 6. Okay, let's see if that makes sense, right? Let's just draw vector AB. Vector A is at 1, negative 3. I'm sorry, that's the initial point A. B is at 1, positive 3 here. So that's vector AB, right? So let's see, is our vector form the correct recipe to draw this? The vector form is, I'm sorry, the component form is saying start at the initial point, go 0 horizontally, and then go 6 vertically. Yeah, that's a perfect recipe for this, right? So that is the component form of this vector. Okay? All right, yeah. Huh? Fine. So, okay, so how do we find magnitude? Yeah. Okay, so how do we find magnitude? So let's talk about the same vector here. This we said in the example above, it has a length of 3, and this has a length of 4, right? And so like when we did number 25 for the homework, how did we find the magnitude over there? We did the Pythagorean theorem, right? Okay, same thing over here. Pythagorean theorem or distance formula or whatever, hang on. That's how we find the magnitude of vector v. So to find the magnitude of vector v, you're gonna do the square root of the first component squared plus the second component squared, okay? Now there are many ways of writing it. One way of writing it is this. The magnitude of vector v is the square root of the first component squared plus the second component squared. And now if you're like, wait, well, what is a and what is b? Well, a is x2 minus x1 squared, right? And then b is y2 minus y1. So there are different ways of writing the same thing. What does that remind you of? What formula? Aside from the Pythagorean. Aside from that. Distance formula. That's exactly the distance formula. Okay, yes.
But, okay, so if we're using the Pythagorean theorem, then why do we just have like vector a plus?
No, that was a different example. Okay.
But that's still the magnitude.
No. A plus b, this is the resultant. In vectors, when we add vectors, this is how they add. So a plus b is just another name for this vector b. Okay? But to find the magnitude, you're going to do the magnitude of this squared plus that squared and so on. Yep.
Isn't this the same thing as
Literally what we just said. Yes, we did use the Pythagorean theorem for this. Yes, good. Okay, good. We're making those connections. So now let's find the magnitude of AB, right? So this is the same vector as example 1. Write it in component form. In component form, this is 0, 6. Yes? The magnitude of it is 0 squared plus 6 squared, which is just 6. And if you look at the vector that we had drawn up there, is the magnitude of that just 6 units? Yes. It is. So this is a good way. Okay? Okay. Yep. We're moving on. Okay. So, okay. So, okay. How do we add and subtract vectors? Okay. So, to add and subtract vectors, suppose you have vector A, it's got its components, and you've got vector B, it's got its components. You just take the corresponding components, and then you put them in the corresponding spot. Now, what does that remind you of? Matrices! Okay, and so guess what? If I have a row matrix, isn't that the same thing as the component form of a vector? Yeah. It totally is. In fact, when you go to college and you take linear algebra, you will see that matrices are just a series of vectors. Vector 1, vector 2, vector 3. Isn't that cute? Yes. Okay. This is how, the deeper you go into math, the more you see that there is like this nirvana out there and everything you've learned is related. Everything. These are just little components. That's why when we tell you, no, we don't want you to solve it that way, we want you to do it this way, it's because we know what's coming later, because you have to look at it a certain way. Okay, let's move on. So here we have vectors w, y, and z. We're going to find 2w plus y minus 4z. Okay. So this is 2 times vector W plus Y minus 4 times Z. So when you distribute, this is 4 comma negative 10, 2 comma 0. And then here it's your choice. You want to distribute just the 4 or the negative 4. If you distribute the negative 4, then it'll be plus 4 comma 16. Everybody with me? So now we literally just add the x components, 10, and then we add the y components, 6, and that's the sum of that. I know. Isn't that cute? Yep. Okay. So, okay. A unit vector. What is a unit vector? Okay, so vectors come in all sizes, okay? With all sorts of magnitude. We don't judge. But sometimes all you need is the direction of a vector. All you need is to say, okay, you know what, like you just have to be pointing in this direction. You don't need a vector like, 760 units long. You just need the direction. So in that case, what we do is we literally scale down the vector so that it has just a length of 1, and we call that a unit vector, okay? So if I had a vector of length 5 and I wanted to scale it down and make it a length of 1, what would I do to the magnitude?
Multiply by the square root.
You divide by 5, right? You divide by the magnitude. So here, I have a vector which is 2.5 units long. If I want to scale it down and make it 1 unit long, I just have to divide by 2.5, okay? So that means I take the vector v and then I divide it by the magnitude of the vector, and now that becomes a cute little vector which I call U for unit vector. Mathematicians are just not very creative when it comes to like labeling things, right? U for unit vector, V for any old vector. Okay? So here, oh, my symbols disappeared. These should all be, okay? So that's how you find a unit vector, U. Okay. So let's take a look at this unit vector here. We want to find a unit vector U with the same direction as V. Okay, so first what I need to do is I need to find the magnitude of V. So that will be the square root of 16 plus 4 root 20. And of course, we always have to simplify our roots. So that will be 2 root 5. Now, to find the unit vector, I gotta do vector v divided by magnitude of v. So that's gonna be a vector v, 4 comma negative 2, over 2 root 5. Okay, so this is like dividing by a scalar, so each component gets divided by it. So it's going to be 4 over 2 root 5, negative 2 over 2 root 5. This is 2 over root 5, negative 1 over root 5. Now, we're going to do 2 very cool things with this. The first thing we're going to do is the following. So this is presumably a unit vector, right? But is it really a unit vector? Does that really have a magnitude of 1? Let's see. So how would I find the magnitude? Square the first one. When you square it, what do you get? So 2 squared is 4 over 5 plus square the other one, 1 over 5. And that would be the square root of 5 over 5. Oh my God, that's like totally a length of 1, right? So now we're going to do something else. Because now you're like, oh my God, Miss Malikan, there is no way that is a unit vector of that one. So let's see. Okay, we are going to test this out. Okay, can somebody please put these in the calculator and get decimals? So by the way, to give the answer, like these are fine, like 2 root 5 and 1 over root 5. Can somebody tell me what 2 over root 5 is?
Point 0.89.
Right, 0.89. And then, so it's about 0.90. And then the other one is half of it, right? It's 1 over root 5. So it's about negative 0.45. Yes? Okay, so take a look at what we're going to do. We're going to draw here vector v. Nope. I'm going to show you right here. I'm trying to get my... Okay, here I'm going to draw vector v. So what is vector v? 4 comma negative 2. So why don't we go ahead and do that? This is going to be vector v. 4, I'm going to go over 4 and go down 2. Everybody believe me that that's vector v? Okay. So, and then how much was vector u? It was 0.89 and negative 0.45. So take a look. Let's draw that one now. So from here, I'm going to go 0.89, which is about a 1, but not really. And then I'm going to go down about a half. And look at that, boom, it coincides exactly on top of the other vector. So do you see how it's got the exact same angle, but it only has a length of 1, right? So that is the unit vector for this, okay? Do you have to do this every single time? No, I was just showing you how this works, okay? All right. Okay, any questions?
Yeah.
Yep.
Like when you wanted to check if it was right, like why did you do like the 4 bits plus like 1?
Because I wanted to see what the magnitude was, and we find magnitude by squaring this plus squaring that and adding it. Okay? All right. So that is a unit vector. Now, unit vectors can point in any direction. However, there is a special set of unit vectors that lie on the positive x-axis and the y-axis. So those special unit vectors, like this red one here and this blue one that lie on the x-axis and the y-axis, these have special names. They are called vector I and vector j. But the way we write them, right, vector I, you do it in, italicized I, just like the imaginary number I. But how can we tell apart that this is a vector and it's a unit vector? You give it a little hat, okay? That's literally a hat. And guess what that's called? That's called I hat. That vector is called I hat. So I hat has components 1, 0, because it's got 1 unit horizontally, 0 vertically. Its buddy is j hat. It's 0, 1. I hat and j hat. These are like, they're buddies. Okay? Years ago, I have this wonderful idea. Now, don't steal it, okay? When I retire, I'm going to create a cartoon called The Adventures of I Hat and J Hat, and they're just going to be like these two little vectors like that go around and like get into trouble. Wouldn't that be cute? Would you watch that? I mean, you'd be too old by then, but your kids might. Your kids might. So because I hat and J hat are always in cahoots with each other, because you can get, a series of I hats, you can get 3 I hats.
You only get up.
No, you can get let's say you get 3 I hats, and then let's say you get 4 J hats, and together you can create a vector that has components 3, 4. Yeah, isn't that cool? So now, this is the component form of that vector. However, you can also write it in terms of I and j. How do we write that in terms of I and j? Well, you say, well, you get 3i hat plus 4j hat, and that is the same thing as that. So if I was walking down the street and I saw a billboard, and on the billboard it just said 3i hat plus 4j hat, I'd be like, that's a vector with components of 3 and 4. Okay? Right. Yes.
Where do we get the 3 and the 4?
I just made up 3 numbers because on that diagram there were 3 red vectors and 4 blue. Okay, so take a look here. Let DE be the vector with initial point D, terminal point E. Write this as a linear combinations of the vectors I and j. So in component form, DE, is what? So 6 minus negative 3, 9. 2 minus negative 3, 5. But as a linear combination, it's a mouthful.
Wouldn't it be 5? 2 minus negative 3 is
X and then Y. Why is it not?
Oh my goodness. It would be 5 comma 9. What did I do? I did slope. Okay. It's 5 comma 9. But as a linear combination of I and j or whatever, DE would just be 5i. Whoops. Oh my God. I'm mixing my i's and j's. Don't you hate that? 5i plus 9j. Okay? All right? So it's I hat and j hat. And these are like well known. And this actually, like, it's an accent mark in French, right? You know how like there is the actual accent like this, and then there's that accent mark, and like they also call it like a chapeau, like it's literally a hat. Okay, so it's I hat and j hat. All right, so that's where we're gonna stop today. Okay.